Hi, and welcome to Intro to FreeNAS. My name is Linda Kateley. In this class, this is an introduction to using FreeNAS. The things that we'll go over today are an overview of the GUI, get you an understanding of where the icons lie and what they do. Then we'll dive into some of the basic settings you should set when you're starting your configuration of your storage system. Then we'll start looking at some of the storage basics. I'll start off with just a brief introduction to ZFS, which is the underlying file system in FreeNAS, and then we'll do some sharing. We'll do the AFP, NFS, and CIFS. We'll take just a real quick trip down the road of iSCSI and show you just a real simple basic configuration for iSCSI. This class is the introductory class. We've started a certification program for both TrueNAS and FreeNAS. Each track, the TrueNAS track and the FreeNAS track, contain 4 classes. This class is a prerequisite for both certification tracks. Some of the classes are the same for the TrueNAS as the FreeNAS, and there's a couple of them that are different. All the classes are live and virtual. They're set up on Wednesdays or Thursdays at different times during the month, and they're limited to 10 students, so you have a lot of chance to ask questions and have good feedback and good discussion. All the classes are less than half a day. They're designed so that you don't have to go sit in a room for 2 to 3 days just to learn how to do your job, let you do your job and take classes at the same time. That saves you on time and travel costs. And then in the certification classes, there's lab work that you're assigned to do after the class at your convenience. Do it the next day. Do it sometime when you find some free time to get that lab work done. So we won't schedule lab time within the class, but you can finish it up when you're done. In the TrueNAS certification track, this is designed for the TrueNAS customers, partners, and resellers. There are 4 classes for TrueNAS. There's the admin class, there's the sharing class, there's a class on cluster and failover, and then there is a fault analysis workshop. So those 4 classes need to be completed, plus this introductory class for the TrueNAS certification. For the FreeNAS certification, this is designed for community partners and independents, or just anybody who wants to build a FreeNAS system. The classes in that, there's again 4 classes. There's an admin class where we go over things, more deep details about how to manage the storage, how to replace a disk, how to run upgrade, those kinds of things. Then there's a deeper dive on sharing, some of the tweaks and turns you can do for the different sharing protocols. Also, we go in depth on CIFS and Active Directory interoperability, and then iSCSI going kind of beyond the defaults. And then because FreeNAS isn't tied to a hardware platform, there's a class around doing hardware design, architecting systems for different uses. So that's a little bit shorter class. That's a 2 to 3 hour class where we kind of go over the different components of a system, how much CPU, how much memory do you need on a system to run, backup and archive versus a database, different design configurations, different ways that you would build that. And then the fault analysis workshop is the same as the TrueNAS class. And that's really looking at if there's problems on the system, looking at debug information, trying to identify root cause and solve some problems. People that complete the FreeNAS track and get certification, there is a lot of demand for contract consulting in the FreeNAS environment. So we'll be able to put you in that pool for contract consulting. Before we get started, just a little bit of background on me. I've spent more than 20 years working with Solaris and other Unix distributions. I spent more than 10 years as a global Solaris expert for Sun and then Oracle. I spent more than 10 years of my career as a technology instructor, teaching Solaris administration. Also, when ZFS was launched, I was one of a handful of people that taught Sun's Field how to use ZFS, where to, how to architect it, how to work with it. And then over those 10 years, I've taught, hundreds of the Fortune 100 customers, Fortune 500 customers, how to use ZFS, where to put it, and how to architect it. So let's get started. We'll start off with an introduction to the GUI. So when you log into the GUI for the first time, you'll notice that there are icons across the top. They're designed to be like shortcuts to the individual topics. The items down the side are for primarily for legacy use. FreeNAS has been around for a long time. It was around a long time before ZFS came on the scene. So those items on the side are for legacy users. Over 6.5 million downloads of FreeNAS. Don't really know, which people have, are using it for what. So those legacy things stay there. And then also down the side are expanded topics or more information on the individual topics. So let's get looking at the GUI. When you first go to log into the WebGUI for your FreeNAS system, when you install the system, the network interface will automatically do a DHCP on your network and give you the IP address that you can use to access the WebGUI. I'm using this on a client system on the same network. You can use this, though, that IP address on any client system on the network with any commodity web browser. So you type in the IP address. The first time that you log in, it'll have you set root password. You can set this password to be whatever you want it to be, as long as you remember what that is, and then click login. As you log in, you see the different icons along the top. These are for the basic areas, the general areas that you will need to configure your storage. Starting with system. System is most of the system settings, things like time zone and time servers, those kinds of things, configuring email and user accounts. Network allows you to do many things on the network. You can just have a single interface or multiple interfaces, or doing things like aggregations or VLANs. The storage is where we'll spend most of our time today. Storage allows us to create storage pools and then break those pools into data sets, and we'll have much more of that coming as this class continues. Then once you configure those data sets, then you can share them out over the network. So that's where you configure your AFP, your CIFS, your SMB, NFS, and iSCSI, or not the iSCSI, just the file-based sharing protocols. Then we have services. There are other network services that are available, things like FTP, and this is in the services is where we would configure iSCSI. There's also a lot of plugins out there. There's plugins for things like DLNA for media servers, and for there's a number of backup utility plugins. So the plugins extend the use of your FreeNAS server by adding additional functionality. There's also the jails. The jails are very lightweight virtualization environments that allow you to run applications in a very lockdown way. We won't be covering that in this class. And then there's the reporting. Reporting gives you information about what's going on the system, the CPU consumption, the memory consumption, the disk consumption, network bandwidth. So it gives you that information for a short period of time or a long period of time. You can see what's been happening on the system. You get, you know how it goes. You get there and somebody says, yeah, the user, you know, it was slow last night. And you, oh gosh, how do I get, you know, how do I figure out why it was slow? Well, having that reporting capability, you know, give us a good historical view of the system and what was going on, may be able to let you see why the system was slow at a certain period of time. Then on the other side of the GUI here, there's the account information. Account information, user and group information, is used for two different kind of hops of security. First, you have to have, a user has to have access to the share or the data set. And then they have to have access, read or write access to the file. So having accounts defined on the system and understanding permissions, we cover that in a lot more detail in the sharing class. I'll show you how today to just set up a basic account though and make that account have access to the shared storage. There's also a help button. I'm going to click on this real quick. The help button, there's a lot of help out there. There's the community forums, and then there's all these different mailing lists. You may not want to join these lists, but if you're using FreeNAS, at least get on the FreeNAS announce list. If you click this link, it'll take you off and show you how to sign up for that mailing list. If you want to participate in the community in things like development or testing or helping with documentation or translations, there's a mailing list for all of those things. There's also an IRC chat on Freenode, hashtag FreeNAS, if you want to have some sort of real-time answers to questions out there. There's also a bug tracker. So if you are running into problems and you think it might be a bug, you can go out and look and see if that's already something that somebody's found and it's in the process of being fixed, or if you think you found something new, you can, as a community member, you can submit bugs into the bug tracker. There's also very, very good documentation at the FreeNAS documentation section. Everything that I talk about today is also in the documentation so that you can see a visual representation of what we're talking about. The underlying operating system of the FreeNAS environment is FreeBSD. The FreeBSD man pages aren't shipped with the appliance. They try to keep it as small and as lightweight as possible. So if you do have a need for one of those FreeBSD man pages, they're out there in the documentation. There's also professional supported FreeNAS storage or support that comes from iSCSI. So you can click on this button and get access to per incident support for your FreeNAS appliance. There's also, if you want FreeNAS already bundled with some hardware, that's what TrueNAS is. So TrueNAS is FreeNAS plus some hardware, well-vetted hardware, very well configured, balanced configuration for hardware. So you can also just buy it with the hardware software combination. There's also the logout button. Probably the first thing that you should look at when you log in is the alert button. You see my alert button here is green. Green is good. It goes red, yellow, and green. If you see a yellow alert, if you click on this button, it'll tell you what the alert condition is. I'll also show you here in a few minutes how to set up your system to send you email if you go to a yellow or red state. If there's any problems on the system, it'll just send you out an email. But here you'll have yellow means that the system is still functioning, but may be in a degraded format. If it's red, though, there's something wrong where, shares are not accessible or storage is not available. So if you get to a red alert, you need to get moving and see what the problems are. Next, we'll look at basic setup, the things that you need to do to set up your system when you initially install it. The key items that you want to set up is time and time zone information, email notification, and user and group information. So let's go back to our GUI and get into some of the system settings information. So we start off with general settings. What protocol do you want to use to access the WebGUI? Sometimes if you have multiple interfaces, you may want to use one particular IP address for WebGUI access, ports, the language that you want to use, console keyboard layout. Here, time zone information though you want to set. I am in America, Chicago, Central Time Zone. You can set a syslog server here. You can pick out a particular IP address that you send all your log information to. And here at the bottom of the screen, you can set the directory service that you want to get your user and group data from. You can set it to get information from Active Directory. You can function as a domain controller. You can get your information from LDAP, NT4, or NIST. Once you do settings on any page, usually at the bottom there's going to be a save button. So I'm going to click on save so that this is permanent. You'll notice at the bottom here too there's factory restore. Factory restore will take you back to all the default settings. And also if you go into save config, let's say you do make a lot of configuration and changes and add a bunch of users, and you want to save out your configuration information. You can save this config into a config file that will come to whatever system you're sitting at. So if I clicked on save config, I'm here on a Mac, it would save that information onto my Mac. Then if I wanted to replicate that system or have a similar system, or if I wanted to reinstall my head node or something like that, I could run upload config and have all that configuration information applied to the system. Next, we'll set up email. Your FreeNAS system has the ability to send out email to whoever you wanted to send it to if there are errors or some report that's been run or any notifications that you want to know about. So let's look at setting up email. So the system will send email to the root user. So the root user needs to have a valid email address. We're going to configure it to change root's email. So I'm going to click on account here. I'm going to go into users. I'm going to click on the root user, and on the bottom here, change email. I'm going to put in a valid email address and click on OK. Once that's done, I can go into Systems, Settings, Email. The from email, not that important, but what is important is that you put in a valid outgoing mail server. For my Gmail account, I just have a Google Mail here, but you may have your own company corporate email server, outbound email server. The port to connect to, the type of authentication, and then if you're going to use SMTP authentication, if your mail server requires you to use SMTP authentication, which my Gmail does, I have to put in my password here and put it in again so that the system knows, can be authenticated to send email through that outbound server. Once you're done here, you click on save. You can also send out a test email, and it will let you know that everything that you've configured is working. Next, we'll just take a quick overview of some of the advanced settings. Most of the advanced settings, though, are covered in the admin class. So let's go into Settings Advanced. There are a number of things here that you probably will never set. Things like serial console, port speed, enabling screensaver, power demons, things like that. One of the things, though, I like to set is show the console messages in footer. What that'll do is when you click on something, it'll actually show you the commands the underlying Unix commands that are being run. For me, it's nice. I'm a Unix geek. I like to see what's going on underneath. For some people, it's a distraction. It really is a choice, not necessary. Some of these other things are all around, or most of them are around setting up debug information, showing advanced fields by default on the different pages that you go into. Really has to do with your comfort and level of skill. Enabling the debug kernel, the auto tune, these things are covered in one of the advanced classes. Next, we'll look at setting up users and groups. Users and groups are used for access. Who has access to the storage, who has access to what storage, and who doesn't have access. We can set up two different levels of permissions, actually multiple levels of permissions. We can set up permissions based on the share and the share type, what users, groups, maybe even IP addresses can have access to a particular share. Then we can set an owner and group ownership of the data set being shared, and we can also set up very granular permissions at the file level. So the box your FreeNAS box needs to have knowledge of users and groups that are similar to what is available on your network. Now you can set all this stuff manually in your FreeNAS box, or you can get this information from a directory service. We interoperate with Active Directory, with LDAP, NIS, or NT4. So to set up a user, let's go into Account, Users, and Add User. To add a user, it automatically increments to the next available user ID number. You may have a user ID number that you're already using for a user on the network, so you can set this to be the same. The next thing that we want to set is the username. It doesn't have to be a name. It can be whatever string of characters you want to use to identify this user. You can have it create a new group for the user. So if maybe you have a share that you want to share with engineering all equally, you may have a username of engineering and a group of engineering and set all the permissions the same. In this case, though, I'm going to set this user to the wheel group. The wheel group is considered a higher level group, an administrative group. There's also a predefined group in here that you can use. Staff is here, so you can use this one for your users, or you can create and add groups just like you create and add users. In this case, it's going to be the wheel group. It does have the ability to set up home directories in a particular directory or pool. I don't have any pools configured right now, but we can come back to that. We can then put in the full name of the user, and an email address for the user. Then a password for the share. We also have the ability to disable password login, meaning that they can't log into the box. We can lock a user. This may be after, typically you don't lock a user when you create the user, but you may want to lock the user. Jim just left the company. We want to lock down the account until we know what to do with the files. Permitting sudo access allows this user to do root-like commands on the system. And we can put in the SSH public key. We can also add additional group memberships for this user. I'll click on OK, and that user is added to the system. Tells me up on top here, user successfully updated. So now we'll get into the nuts and bolts and get into managing some storages, which is what you want to do with your FreeNAS. Just a little introduction to ZFS, what it is and where it comes from. ZFS really comes from the idea of consolidation, where I have multiple workloads on the same frame. But I want to be able to buy disk and share the different disks between different workloads. The world that we live in now is just massively consolidated, and we run into problems with, how do we adequately share disk amongst different workloads, but also keep a firm separation or boundary between the workloads. SAN, when SAN first came out, it was the answer to this question. The idea of having, a storage area network, having all the disks in a single frame, and being able to partition or portion out a piece of those disks to the different workloads that were attached to that storage area network. In practice, it didn't end up that way, right? You can't, in most SAN environments, you can't easily re-provision disk from one workload to another. So NAS has become kind of that more readily available device where I can share things, share files between different systems, but I also have to be able to do it securely, and I also have to be able to guarantee certain service levels per workload on a NAS environment. NAS is nice, if you look back 5-10 years ago, NAS just wasn't even looked at as a solution because the latency numbers to begin with were bad, and then the bandwidth numbers weren't there. Nowadays, we can run, shared network file system, network attached storage over very high performing media. So, some of those reservations around NAS kind of have come out. Also, the cost differential between NAS and SAN, very difficult. Now, when you start looking at ZFS, what you can see that ZFS can do is that it can do both, right? It can take a server, put a bunch of disks in that server, and have it just kind of logically carve out some of the disk or for SAN, or we can use that file storage for NAS. We can do both. And then also with ZFS, one of the things that it does probably better than anything out there is repurpose, right? If I want to give one workload 10 gigabytes of disk space and then next week give it 20, it's one command, it's one click to grow those things and repurpose or reprovision the disk space. Also, the other thing that ZFS is exceptionally good at is the adding more storage in. Big sandboxes, big NAS frames, you want to add some disk to them. Sometimes you can, not always easily. And some of them it's buy a new frame, when you need to get more disk. ZFS runs on commodity hardware. It loves commodity hardware. Give it a x86 CPU. I run it on my laptops. I don't need any special hardware. I don't need any special purpose configurations to do both NAS and SAN. So the cost beneficial is enormous. I have the same kind of software in the high-end NAS and SAN environments that I do here with ZFS. It also has things like, there was a day and a time for your SAN frame if you wanted to add something like snapshot capability. It was there, it was available, but you may end up paying a quarter of the price of the entire storage just to add that kind of snapshot capability. all of this is built on OpenZFS. OpenZFS has snapshotting built into it. It has cloning built into it. It has checksums built into it. It has all of these feature functionality built into it. In this class, we're just going to talk about creating, though, some storage, carving it up into different data sets. But know that in the additional, in the admin classes, we do talk more about some of those special features, about repurposing the hardware underneath. I will show you how easy it is to add storage, though, to the frame. So let's get started and let's start creating some pools and working with ZFS. So we're back in our FreeNAS WebGUI and we want to start working with storage. So I'm going to click on the storage icon. Now what it tells me right away is that it doesn't have anything configured right now. I'm going to click on the ZFS Volume Manager. Now the first thing I have to do with the Volume Manager is give it a name. You can create different pools on the same box. They don't share storage between the boxes or between the pools. You have to assign disks to a pool. Once you assign disks to a pool, those disks are shared with whatever data sets we carve out of them. So I'm going to start off with a pool name. If I were adding additional disks to this pool, I would just click on Volume to extend. I can also use encryption here with the FreeNAS tool. Now it does show me here that I have 4 available disks, 4 available 500 gigabyte disks, and I can see the different names of them here. And I have two small SSDs here, 63 gig SSDs. I'm going to start off by just clicking on the 4 disks that I have. Now, one of the great things about the FreeNAS tool is that it automatically lays this out into what is considered an optimal best performance and best redundancy for this kind of configuration. Now, I don't have to use the optimal, though. I can take this little knob here and I can move it around so that I have different ways of doing this. Like I can pull it out to a RAID Z, which is a RAID 5. For now, just think of it as a RAID 5. It will pull it out. We can pull it in. It will tell me, if I do it in this format, what my capacity would be. Nothing is done, though, until I actually click on the add volume. I'm just going to, for now, just have 2 mirror disks, and I can add an extra device here. For now, though, I'll just create this pool. Now I'm going to click on Add Volume, and it will then add this pool. Now, as soon as this is done configuring the storage, it's ready to go. It actually mounts this to a mount point of /pool or /mnt/pool, big pool, the name that I gave it, and it's ready to go. I could share that data set out just as is. Or I can create additional data sets, and a data set is very similar in nature to what you would consider a file system, legacy file system, and I can use that. I can maybe carve it into different data sets, maybe some for the CIF share, some for the Unix shares, some for the Apple shares. I can then carve the shared pool up any way that I want, or I can just use it as is. So now let's say I have this pool. I want to add some additional disk space to that. I can go back into my volume manager. I can click on my volume to extend here, big pool, and I say add these couple of disks. I'm going to add these 2 disks to my pool. And I can say extend volume. The thing that's really amazing to this is that I don't have to take users off the system. I don't have to worry about outage or downtime. I click on extend volume and it will, the new disk space or the additional disk space will be available as soon as this command completes. So now we see that, the amount of space that it uses, very little. ZFS doesn't write anything to the disk until there's stuff to write. The percentage of the whole for metadata here is very tiny. And you can see how much space that I have available, the kind of compression I'm using by default. Now, if I want to, though, I can go down the bottom here. If I click on my pool, there's a number of different items that I can do. I can detach this. We'll talk about scrub. We can edit some of the ZFS options here. Create dataset. We're going to create some datasets here in a second. Create a volume, which is carve out a set of blocks to use maybe for an iSCSI target. We can change some of the permissions on this pool, and we can create snapshots. Or I'm going to click on volume status here. What's interesting is when I added that second set of disks, it's created a second mirror. So by default, the way that I've set the system up, it's 2 mirrored pairs that it is going to stripe on top of it. ZFS uses this concept of virtual devices. Every device that you put into a pool becomes a virtual device, and it will always stripe across your virtual devices. This gets a little bit interesting if you're new to ZFS and you start creating like RAID sets. You create a RAID set and then you create another RAID set. It's going to see each of those RAID sets as its own VDEV, and it will automatically stripe across them. So understanding how your layout looks. Now, the other thing that we have with ZFS, if I go into storage here and I go into the ZFS volume manager, I'm going to extend big pool. Now I have these 2 SSD drives. ZFS can create quite easily what's called in the industry hybrid storage. So we can front end the storage with a little bit of SSD. We can create, it's not really a write catch, but it's a log file, or we can use SSD for log information, and we can extend the read cache from memory, system RAM, out into these SSDs. To do this, I'm going to just take one at a time, and I'm going to take one of them here and make a log device, add an extra disk here. I'm going to take my other SSD and I'm going to create it into a cache device. So with just a few clicks here, I've created hybrid storage. So the next thing that I'm going to do is I'm going to take this storage and I'm going to assign it to different data sets. Data sets is just kind of a logical grouping of the storage available. I can create a data set here, maybe for all my Apple shares, and click on Add Data Set. Now that may be all that I want, or I can continue to create data sets for different workloads. Maybe I have some VMs out there and I want to create a set of space just for VM1. Maybe I have some databases out there that I want to create a data set for those databases. But I can create as many data sets as I want. By default, it shares the space of the pool. So let me create a couple more here. Add data set for maybe my CIF shares. I'm going to set that up to be separate data, a separate data set in big pool. I'll add another one for maybe some NFS shares, a Unix share, add data set. So by default, again, all these data sets share the same space. Now, I may not want them to share the space. I actually have 13-year-old twin boys. I don't think they're capable of sharing. I think there's something genetic about their inability to share. And that's the way, sometimes that's the way users tend to be. If there's something available to be shared, they want to take it all. So I can also have some other settings here in my data sets. So if I go into a particular data set and I want to edit my ZFS options here, and I go into advanced mode, I actually can control the amount of space that any particular data set has in a particular pool. And I can do that by setting a quota. Now for this one, I'm going to just say 900G is available for this data set. I can also create data sets inside of data sets. So in the Apple data set, I can say Apple's user 1 and Apple user 2 and Apple user 3 or Apple user 1 / apps. So I can create as deep a chain as I want. So a lot of the configurations that you find in FreeNAS are around, do you want to set it for this level, or do you want to set it for this level and all of its children? So we can set those things logically for each of these data sets. In this case, I don't have any children, so I'm just going to say set the quota at 100 gig. Now, if I set the quota at 100 gig, it says that it's going to limit the amount of space that this data set has in this shared pool, but it doesn't guarantee anything. It doesn't guarantee that the Apple share will have at least 100 gig to use for itself. That's where we use reservations. So I can put in here 100 gig. So I can set a reservation or a quota of 100 gig and a reservation of 100 gig. And that would give us something that's very similar to what we typically think about with a file system, where it has a limit and it's at least. Now, the nice thing about these logical data sets, though, and this is really where it veers from the idea of a file system, is that we can change these at any time, right? If I want the quota today to be 100 and all of a sudden that project takes off and they need more disk space, I don't have to, clamor for more disk space. The disk space is shared. So I can just change this, tomorrow I want it, okay, I'm going to up this to 150 gig. And as soon as I click this, that space would be available to, I could have writes in flight and that space would be available to the share. Now, if you see what's happened here, though, for this particular share, it has 150 gig available and its size is 150 gig. Now, what you've seen happen with the reservation is that it's actually taken that 150 gig away from all the other data sets here in that reservation, so that it makes sure that this one doesn't grow beyond 755 gig. I always recommend to people that are just starting to work with ZFS, set quotas and reservations. It's more like typical file systems, and you can always change them. You can change them on demand. You can change them with in-flight writes. So using quotas and reservations help you control, or you can just let them share. I try to imagine taking my 13-year-old twin boys and telling them to just share. That probably not a good way to do things. So I like to set control mechanisms to begin with as I start. There are also other benefits to creating these data sets. Each data set has over 40 different things that can be configured. So I can set the way that the data in that data set is written into the pool. I can set up different compression algorithms. I can set up different block sizes. There's a number of things that I can set per data set to configure how that data is written into the pool. The other reason that I want to configure data sets is that a data set is the place at which I can take a snapshot. I have to have a data set. I can't take just a regular directory, and it looks like a regular directory, but I can't take a regular directory and create a snapshot of a directory. I have to create my snapshots at the data set level. So thinking through that when you're starting building your FreeNAS box is helpful, especially how you're going to snapshot. And also, so there's snapshots here. There's periodic snapshots where we can set it to set a policy around those snapshots that say take your snapshot every every hour for a day, or, there's a number of different things that we can configure in that periodic snapshot to determine, not only how often we take those snapshots, but how long we hold those snapshots. A year, 2 years, 10 years, a week. It depends on what the data is. So we can set that policy up in periodic snapshots. At the snapshot layer, that's also where we can do ZFS replication. We can do ZFS replication between FreeNAS boxes. So I may have a box in one data center and I want to make an exact replica in another data center. I may not want to do it of the whole pool. I may just want to take it of the active part of the pool. One data set that I may want to replicate my CIF share to, one host, and I may want to replicate my VM share to another host. So determining how you create your data sets really has to do with, first, do you want to control the amount of space it uses? Do you want to configure something differently than the defaults for the different, up to 40 options? How do you want to take your snapshots? You may have different policy, especially if you're, somebody like a hosting environment. You may have different SLAs with your different customers. This VM needs to be snapshotted more often than this one. So, being able to make that granular is a nice thing. Determining what needs to be in what data set and how you do both the snapshots and the replication is something that you want to think through as you're building your system. So next we'll look at sharing. By default, there are 3 different sharing protocols. There's the AFP for the Apple systems, there's the CIFS for Windows, and NFS. NFS is interesting. It's kind of having a rebirth. NFS has been around almost as long as I have, but it's been around 20 plus years. It was typically thought of as a Unix-only file system, but it's kind of having a resurgence because it's available everywhere. It's like every different platform, Apple's, Windows, Unix, all of them have access to NFS. The big difference between the AFPs and the CIFS versus the NFS also is that NFS is a synchronous protocol where AFP and CIFS are asynchronous. This may factor into the decisions that you make on which protocol you use. There's also iSCSI, so I can create an iSCSI target relatively easy. There's like 6 steps though involved in setting up a default iSCSI target where with the sharing protocols you kind of click on a data set and say share. It's not that difficult. The iSCSI isn't that difficult either, and a lot of the VM technologies like a block device. The difference between a sharing protocol, though, is that more than one system can have access to it, where with iSCSI, it can only be attached to one thing to create, and it's a block level device that whatever that thing is has to create a file system on top of it. So we'll go through the different sharing protocols here and show you how to share your data sets. So to start sharing, I'm going to click on the sharing icon. Now it has the different sharing protocols here. I can click on each one to add Apple Share, Unix Share, or CIF Share. Let me start off with an Apple Share. I'm going to say add Apple Share. Now as I go in here, it's going to ask me to give it a name. I might just call it the Apple Share or Apple Share. I can set up a comment here. Let's say, maybe it's for, engineering or accounting or something. I may want to put additional characters here to help me remember what this particular share is for. Then I want to pick what data set I want to share here. And if I click on browse, it'll take me through MNT, Big Pool. I can, pick from any of these, and I'll click on the Apple. Now I also have some, and I said this earlier about I have some control mechanisms that I can set in the protocol. So I have both an allow list and a deny list. These are at the user level, so I can put Linda in my allow list. Now, as soon as I put a user in the allow list, everyone else is denied. Same is true is if I start putting in users into my deny list, everyone else is allowed. So be careful with your allows and your denies to set them up in a way that you want to have access. Sometimes people use users or groups as, you know, a better way to do this. We also can set up read-only access here. An addition to the Apple protocol that the other ones don't have is the time machine. If you use a Mac, you probably know what a time machine is, where you can have your Macs automatically back up on a regular cadence to this device. I have the FP Unix permissions, and then I can set here my default file permissions. Now, these default file permissions are for when I create a file. Once I have access as a user and I create a file, what would those default permissions be? I don't know why I always like to set stuff like this. If I go through the bother of setting up owner and group, other just is meaningless to me. Maybe read access to other, but you know, setting up your default file permissions here are different. Those file permissions can be set and changed. Don't necessarily need to stay that way, but if I create a new, this is how they'll look. So once I click on OK, it'll say, well, the service isn't running. If this is a new, fresh install, the service will not be running. Do you want to enable the service? Click on yes, and it will turn on the AFP, and that file system will be, or that data set will be shared out over the network. Now, one other thing that I need to do before I can access this is by default, the data sets are owned by root. If you don't know what root is and you know, kind of new to the Unix speak, in Unix language, root is really not necessarily trusted. So I'm going to change this. I would always change this to a user, the user that now becomes the owner of this. And then once the password is given, or anyone from the wheel group would have access to this, this share. So changing the permission of the share is typically important. It does talk about the different access control lists. There's a Windows, Mac, or Unix. I use a Mac a lot, so my Macs are very close to Unix. I also like to set my permissions recursively. That means that any new directories that are created underneath this directory would also be owned by this user. So I'm going to click on Change. And as soon as I'm done with that, I can now access this share from my system. So now on my system, I'm actually running on a Mac. If I want to have access to that, I really only have to go in and get a new Finder window up. On my shared, you'll actually see the shared sitting out here, my FreeNAS box. I do this so often, it actually has it in my memory, but I can connect to this share then as a particular user. And this share now is available to, and it shows up as an icon here on my system. I can start, you know, throwing some data out there and using this network space. So the next thing that I will do is I'll create a CIF share. So I click on the Windows CIFs. I'm going to add this share. Now I start off with needing a name. I can call it really whatever I want. I can add a comment that will describe this. I go into Browse and I find the data set that I want to share. Now you don't have to have separate data sets for all these different shares. Again, data sets are about organizing your files in a way that works. We can add guest access to this. We'll click on OK. and it should ask us, do you want to enable the service? Now, if you do a second one or a third one, you're not going to need to enable the service every time, but it will turn on that service for you, and that share should be ready to view. For testing, I'm just going to use a Ubuntu VM. So now when I go into my file folders and I go into network, you'll see that there's a multitude of FreeNASs here for my Ubuntu client. The first one, let's see what this one is. Oh, there's my Windows share. So that's there and ready to go, ready to put files in. So our last share we'll set up here is a Unix share. Add the Unix NFS share. Now all these different shares, sharing protocols have different capabilities. NFS is kind of old in the fact that it's just when you look at who can have access and who can't have access, it's very network based. So I can say I can't necessarily say user based, but I can say just allow users on the 192.168.1.0 network. Or I can say particular IP here, IP addresses or hosts that are allowed access. All directories, I've got read-only. Now, the other thing that's kind of nice about the NFS too is that I can map my users. So I can say any user that you find, map them to the user Linda. Because that's the only one I have defined here. I don't have the connect capability that I have with the Apple and the CIFS, so that a user can kind of log into the share. So I do have to set up and make sure that my users are granted access. Now I can set map all or map root user. That says map the root users to this particular user, or I can say map all. So that would include the root user. If I go in here to path, I go into browse and determine what files, what data set here, and here I set up my Unix. So that will be the one that I will use, and I'll say OK. It should turn on the service and make that now available via any system that has NFS capabilities. Enable the service. OK. And again, the difference between the NFS and the CIFS and the AFP is that NFS is a synchronous protocol. When you add the SSDs to a system, they'll have some impact on the performance of NFS shares. So that it is available to you because it's a synchronous technology rather than an asynchronous technology. So the last protocol we're going to look at here is iSCSI. iSCSI likes to use a block device. So what I'm going to do in BigPool is I'm actually going to go down here and I am going to create a ZVol. What happens when I create a ZVol is it just carves out some blocks within the pool to use as a block device. So I need to give it a name. I like to call everything Bob if I can. I have to give it a size. Now, once I give this a size, it doesn't mean that I can't change it. I can make it bigger or smaller later on. I can have it be a sparse volume, which makes it so that it doesn't use any space on the disk until there's stuff to write. There's also a number of things in advanced mode. We do cover the iSCSI targets in more detail in the sharing class, but for now I'll just show you how to create a basic iSCSI target. So I have my ZVol here created, and now I will go up here into services. I'm going to turn on iSCSI, and I'm going to click on edit. Now, the easiest way to just create an iSCSI target is to just walk along the top here. Using the defaults, again, very easy. Configuring outside of those defaults, you'll see, if we go into portals and we add a portal, there are ways that we can do this outside of the default. The default is just to, accept requests on any IP address. But we can add multitudes of those. We'll just say OK for now, though. We're going to say OK. So we have a portal group that we've created. Initiators, we're going to add an initiator. Say OK. Creating authorized versus unauthorized access. Again, a lot of details around that. For right now, we're just going to say everybody has access. We're not going to discriminate. Then we'll go into targets, add a target, give the target a name. I like to call things Bob. What access it has. Now, really what we're doing with the target is that we're creating a named device that is available for a particular portal group and a particular initiator group. Again, we can change some of the other variables in here. For now, though, we'll just use the defaults and say OK. Now the next thing is the extent. We'll add an extent name, just call it Bob. Now here we have the choice of it creating a file, a virtual file for this, or using our device. So when I click on device, you'll see that my ZVol comes up here. Now, there's a lot more things that you can do with iSCSI. You can actually give it a physical disk or a portion of a disk or an SSD or so there's a lot of things that you can do here. By default with ZFS, we're just going to use a ZVol. Click on OK. Now the very last thing that I have to do with my iSCSI is do the association. So I'm going to add a target and extent association. So here I'm going to have it create its own LUN ID. We're going to take my target that I call Bob and connect it to the extent or the block device I called Bob. Click on OK. And as soon as I'm done with this iSCSI target is available for initiators out on the network. So I'm going to give you a little bonus content here. We're going to talk a little bit about snapshots. Snapshots are probably one of the more powerful tools in the FreeNAS box and in ZFS. So I'm going to go into click on any given data set and I can create a snapshot of it. So just click like that. When I click on this, it can be either recursively or just at the dataset level. It gives it a name, but I could call it whatever I wanted. I could say this is my Apple one today or at some date and time, and I have it manually create a snapshot. Snapshots are read-only copies of the file system. It's not really a copy, it's block pointers. Come to one of the other classes if you'd like to have better understanding of that. But it's usable. I can have it, I can go ahead for months or weeks or years, and if I want to, I can go back and get older versions of my files in that snapshot, or I can do a full rollback and say, take the Apple snapshot from yesterday and make it my Apple data set today. So I can do rollbacks. I can go in and get files from those snapshots. I also have the ability to take periodic snapshots. So if I add a periodic snapshot, it says enabled, and then it'll ask what data set I want to take this on. So let's say we take Bob. Now, it gives me the amount of lifetime that I have for this particular snapshot. 2 weeks or 2 years. Now it's set up here to begin and end time if I'm going to have an hourly interval. So let's say I have it taking a snapshot once an hour. I may only want to have it do that between 9 and 5 during the course of the day on any given weekday. I may want to set it up to be something that looks like this though. Begin at midnight, end at 1 o'clock. Take my snapshots every day. Let's do it all week long. And keep those snapshots for a year. Say OK. Now I can have a different periodic snapshot policy for each of my different data sets. So, you know, I may want to keep this one for 2 years. I might only want to keep this one for a month, depending on what's in the data set. Now, after I have snapshots, I can also set up replication. So I have to have at least one periodic snapshot of a data set before I can do a replication. But if I do go into my add replication, you can see what it does. What volume data set am I going to replicate? And then the name of that, so I may have it, I might put it in some other directory on the remote system. I can remove the stale snapshots or an older version of the snapshot on the remote side. Now, the first time you do replication from one data set to another, it will take, make a full replication. But over time, with the periodic snapshots, if I'm taking those snapshots once a day, the next time that it does it, it's only going to send the differences between today and yesterday. So it does incremental replication to the remote host. I can limit the amount of kbytes per second if I only have one network connection between the two hosts. I can say, you know, don't use all my network bandwidth while you're doing this replication. Limit the amount. The begin and the end time here. Now the remote host name or IP address that I would want to put in here. Whatever that is. In the remote port, by default, it's sending this over SSH. We may have a dedicated user for this. We may just use the Linda user for this transfer between systems. And one of the things that I have to add is the SSH key for the remote system. So I would get that and put that into this box. Once I click on OK, it's going to take my policy. So that's why it's saying I need to have periodic snapshot set up to begin with. It's going to take my snapshot policy for this data set, and it's going to first send one initial full load of my data set to the remote system, and then it's going to start doing incrementals on whatever my policy is on a daily basis, on an hourly basis, on a weekly basis. It's going to just send the incremental data between the original and today in that periodic snapshot to create a replication. You could potentially set up what I would call poor man's cluster, where you send replicated data, set your policy to once a minute, and have it send over just the differences for that come out in a minute. So you have a very, very near mirrored system. So we've come to the end of our class. Hopefully you've learned some things. Hopefully you've learned these things in this class today. How to get around in the GUI, how to do some of those initial setup tasks, set your time zone, set up email notifications, how to create a basic pool and then add to that pool, add additional disks to that pool. How to then take that shared pool and carve it up into data sets, either 1 or 100 data sets, and then take a data set and share it out over the different networking protocols. Take a snapshot, not only take a snapshot, but also set up periodic snapshots and replicate those snapshots to another host. Hopefully you understand from this first level class that there is a lot more to learn. So we do have the other classes, the TrueNAS, FreeNAS admin class, where we talk more about setting up the system, what things that you can configure on the system, more deep dive on the storage, adding more disks, replacing a disk, those kinds of things, the network administration, creating link aggregations and VLANs. On the sharing, the AFP and the NFS covered a lot of what you need to know about those two protocols. But iSCSI, there's a lot more to learn around iSCSI. And then on CIFS, especially with the interoperability to Active Directory. There are also the two other classes. There's a cluster class coming for TrueNAS, an architectural class coming for FreeNAS, and then the fault analysis workshop. If you have questions, please feel free to reach out to me. I know we don't have the bridge open today, but I'm available on email, linda@ixsystems.com. Or I'm also available on Skype most of the time at Kateley Co. Is my Skype ID, and can either chat or you can show me something that you're running into. Skype's a nice thing to window share. That's all free for everybody. So I do spend a lot of time out on Skype. I'd like to put in a plug too for the TrueNAS system. The iXsystems people have kind of found the right architecture, the right hardware architecture for the FreeNAS product. So they sell it bundled together, the hardware software combination, and then they also have a product that's available that is clustered, so that you can have, you know, high availability solutions, especially in the commercial environment. I've enjoyed my time with you today, and I hope to talk to you soon. Thanks.